One planetary body that has really fascinated astrobiologists is Enceladus, a tiny moon of the giant gas planet Saturn. Here are some basic facts about Enceladus. It was discovered in 1789 by astronomer William Herschel, and it's over 1 billion kilometers away from the Earth. It seems to have a water ice surface, a little bit like Europa, hence the interest from astrobiologists, and it orbits very close to Saturn and its rings, which makes it very difficult to view from the Earth. It's a tiny little moon, about 500 kilometers in diameter, much smaller than the Earth, much smaller than even our own moon. Like Europa, much of our knowledge of Enceladus has been gathered from flyby missions. In 1980 to 81, the Voyager 1 and 2 spacecraft gave us the first images and information on the nature of this tiny moon. And what did it tell us? Well, Voyager saw a highly reflective surface with few impact craters that told us that Enceladus probably had an icy surface that's also very young and active. It discovered a very heavily cratered mid-high northern latitude and lightly cratered region close to the equator that gives us some idea of the differences in the composition of the ice and its age across the surface of the moon. It also found that Enceladus is embedded in the densest part of one of Saturn's rings, the E ring, and it's thought that Enceladus may be contributing material to the production of this ring, as we'll see in a bit. The chief conclusion from what we observed with Voyager is that Enceladus is a young, geologically active moon, possibly feeding the E-ring of Saturn. Many questions about Enceladus began to be answered with the flybys by the Cassini spacecraft beginning in 2004. It returned some of the best resolution images we have of Enceladus. But there's little doubt in saying that its most remarkable discovery was that there are plumes containing hydrocarbons and water being ejected from the south pole of Enceladus, and we'll come back to those in a little while. Let's have a look at some of the interesting features that have been observed on the surface of Enceladus. First of all, the Cassini spacecraft confirmed that this is a moon with a very young surface, a very active surface. Different levels of cratering were found in different areas, but all craters show signs of deformation and degradation, suggesting an icy surface where the craters are collapsing and beginning to subside and dissipate in this active surface. Near the south pole of the moon are features that have been called tiger stripes, which may be as young as 500,000 years old, which is very young in geological terms. They seem to have a different composition from the rest of Enceladus. They contain coarse ice grains instead of fine grains, and lots of organics seem to be present in these tiger stripes. There's little doubt in saying that the most remarkable discovery was these vapor plumes being ejected from the tiger stripes from the south pole of Enceladus. The Cassini spacecraft had the opportunity to fly through these plumes and measure their composition, and it found some extraordinary things. It found that these plumes contain water ice. It also found methane, carbon dioxide, and organic compounds such as propane, ethane, acetylene, and also more complex organic compounds. In fact, the instrument, the GCMS on this spacecraft, was not adequate to identify these very complex organic compounds because it wasn't designed for this task. They weren't expecting to find hydrocarbons in these plumes being injected from Enceladus. But these complex materials, these complex organics, suggest that the interior of Enceladus contains liquid water and might be acting as a huge chemical reactor, producing organic compounds that are being ejected into space in these plumes. And one obvious question for astrobiologists is, could these complex organic molecules indicate life within the moon? And even if there is no life in Enceladus, perhaps these complex organic compounds can tell us something about the reactions, the chemical reactions that are necessary to build the building blocks of life, to create the building blocks of life that are necessary for the evolution of life on planetary surfaces or in the interior of planets. All of these data come together to give us clues to the interior structure of Enceladus. We think that Enceladus contains a rocky core surrounded by a water ice mantle. But the tidal heat generated from the gravitational force of Saturn causes the buckling of this moon that generates heat. This heat might melt the water ice mantle beneath the surface, creating pressurized bodies of liquid water. These pressurized bodies of liquid water then reach the surface where they break out through the tiger stripes and create these plumes, ejecting these complex organic materials into space. A forthcoming challenge of astrobiology is to determine the composition of possible liquid water beneath the surface of Enceladus and what these organics really mean. Could this be a location for extraterrestrial life or just an interesting factory for organic compounds? Future missions to Enceladus are already being planned. The Titan-Saturn system mission has been proposed by NASA and the European Space Agency, and it's a proposed mission to study Saturn's moons, including Enceladus. It lost out on funding and a mission to Europa, but nevertheless in future there will be missions to Enceladus to explore those plumes, to see what they contain, and to see whether they might reveal something about the interior of Enceladus, whether it could even be a location for life. So what have we learned in this lecture? We've learned that Enceladus is a tiny moon of Saturn. It has a young, actively deforming surface. Most importantly for astrobiologists, we've learned that it's spewing out jets of water vapor and organics into space. And it's thought that Enceladus might have salty water beneath the surface that's providing the source of water for these plumes. It could even be a location to search for life.